Hi, I'm Madeline Dennis and I'm a third-year biochemistry major.
Hi, I'm Sarah Scholdberg and I'm a third-year biochemistry major as well.
Today we're going to be looking at the hybridization of certain atoms in the caffeine molecule as well as the number of sigma and pi bonds. Hybridization is the theory that new orbitals form to allow atoms to make new bonds. During hybridization, an s orbital and a p orbital hybridize or combine to make an sp hybrid orbital. Depending on the number and type of bonds, there can be various hybridized orbitals. Let's take carbon, for example. Carbon has one s orbital and three p orbitals. When carbon's bonding, it can decide if it wants to make 4 sigma bonds, which would allow it to have 4 sp3 hybridized orbitals. So that looks something like this. Each hybridized orbital houses one valence electron so that it has the ability to make 4 sigma bonds. Carbon can also form 3 sigma bonds, which means it has 3 sp2 orbitals. Again, 3 hybridized orbitals, each with 1 electron, but that also leaves carbon with 1 unhybridized p orbital, and that's what allows it to form pi bonds. Carbon's not the only atom that does this. Hybridization occurs when any atom is forming a bond. Carbon also has other hybridizations besides sp3 and sp2.
In a molecule, there are 2 types of bonds. You have sigma and pi bonds. A sigma bond occurs when you have 2 orbitals, they are not necessarily hybridized, and they overlap directly. So this right here would make a sigma bond. The pi bonds occur when the unhybridized p orbitals overlap, and the p orbitals are the dumbbell shape, and they're parallel to each other. So this overlap and this overlap give you 1 pi bond. So then we have all 3 types of bonds. You have your single bonds, your double, and triple. And each of these have a different number of sigma and pi bonds. For your single bonds, you have 1 sigma and no pi. For your double bonds, you have 1 sigma and 1 pi bond, and triple bonds have 1 sigma and 2 pi bonds.
Now we will look at the hybridization around the various carbon, nitrogen, and oxygen atoms in the molecule caffeine. We will do one example of each, then give you a chance to do some on your own. Let's first look at one of the methyl groups coming off the nitrogens. This carbon has formed 4 sigma bonds. 1 sigma bond to each hydrogen, and 1 to the nitrogen. 4 sigma bonds means that we have an sp3 hybridized carbon. Next, we will look at one of the nitrogens in the ring, specifically the one double bonded. The nitrogen has formed 2 sigma bonds, but nitrogen also has a lone pair, and lone pairs are always occupying hybridized orbitals. So that means that this technically has 2 sigma bonds plus 1 lone pair, so that means it's an sp2 hybridized atom. And finally, we're going to look at oxygen. Oxygen is double bonded, but also has 2 lone pairs. So that means we have 1 sigma bond plus 2 lone pairs. That's also going to be an sp2 hybridized atom. Now go ahead and pause the video and find out the hybridization of all of the carbon, nitrogen, and oxygen atoms, and then you can double check your answers with us when you're done. Here are all the hybridizations of the carbon, nitrogen, and oxygen atoms. Feel free to pause the video, check your answers, and then we can discuss how many pi and sigma bonds there are in the molecule.
Now let's count the sigma and pi bonds in the caffeine molecule. Remember that Single bonds have one sigma and no pi bonds, and double bonds have one sigma and one pi bond. Let's count all of the sigma bonds together. Remember that the carbons on the methyl group have a total of 3 sigma bonds. There's a sigma bond here, so that's 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, and I forgot this carbon down here, so 22, 23, and 24 total sigma bonds. Now try the pi bonds yourself. You can pause the video now and then check your answers after. Now you know how to determine the hybridization of an atom, as well as how to count the number of sigma and pi bonds in a molecule. Thank you for watching.